We were discussing about the bottom-up parser as well as the top-down parser. In this video, we'll again continue that discussion about the bottom-up parser and how does the bottom-up parsers actually work. Okay, and I'm also going to tell you what are the different types of top-down parser. So assuming that we have the grammar S derives A, B, E, A derives A, B, C/B, and B derives D. And assuming that we want to make the string W is equal to A, B, B, C, D, E. We have seen this example in the previous video, but again I'm telling you. See, some students may be getting confused between rightmost derivation and the leftmost derivation, RMD and LMD. Okay, so we already discussed this RMD and LMD in the other videos, but just for revision purposes, I'm explaining you what is RMD and LMD. And as I told you that this bottom-up parsers uses the reverse of rightmost derivation. What is a rightmost derivation? Rightmost derivation means when you are trying to generate any string, then you replace the rightmost variable from the given grammar. That means assuming that you want to generate this particular string from this given grammar, then how can you do a rightmost derivation? S derives A, B, E. This is the given grammar. Now, in this particular string, you can see what is the rightmost variables. We have two variables here, A and B. So out of these two variables, what is the rightmost variable? Rightmost variable is A. So in the next step, I'm going to replace the rightmost variable. So this symbol can be written as A, and we can replace A by this ABC. So it can be written like this, A, B, C, B, and this is E. Okay, so I just replaced this A with this particular string. Now I can replace the next rightmost symbol. There are two variables here, A and B. I can replace the rightmost A again with small b. So it can be written as A, B, B, C, B, E. Now we have only one variable, that is B, that is in the, now you can replace this variable B with the symbol which is D. So it can be written as A, B, B, C, D, E. This is the rightmost derivation. And when we discuss about the leftmost derivation, that means given a string, right, or you can say given this production, you can see there are two variables here, then we will replace the leftmost variable first as compared to the rightmost. In rightmost we replace the rightmost one, in the leftmost we replace the leftmost one. So here we can write A, D, E. Again, now we have only one variable. Now we have to replace this variable A with its actual value, that is ABC. So it can be written as A, B, C, D, E. Again you are going to replace this A with B, so it is A, B, B, C, D. See, in both the cases you are going to get the exact same string. String will not change. The only difference is what is the variable you are replacing. And when I'm saying bottom-up parser, that bottom-up parsers use the reverse of rightmost derivation. Assuming that we have the following string and we want to do a bottom-up parsing with it. So we have the string A, B, B, C, D, E. Now you can see in the rightmost derivation, I replaced this A. Again, I replaced the rightmost symbol. So we use the reverse of rightmost derivation. That means given this string, can you tell what is the variable which needs to be replaced? Here you can see if we have this particular string, this B can be replaced with A, and further this entire A, B, C, this is A, B and C, this A, B, C can be replaced by a single variable which is capital A, and further this variable D can be replaced by B, and we can use this A, this capital A, this B and this E to be replaced by a single variable which is S, or you can say to be replaced by the start symbol which is S. So you can see when we do a bottom-up parsing, that means the major problem is if we are trying to do the reverse of rightmost derivation, then what is the variable or what is the symbol we should reduce, and to what variable it should be reduced. Okay, for example, here this B is reduced to A, and here this A, B, C, this entire is reduced to A. Okay, so the problem is what variable should we reduce and how do we reduce the variables. Okay, now there are top-down parsers. We are having, as I told you, two types of parser. Then we'll be starting with the top-down parser. Now this top-down parser can be divided into two parts. Number one, top down parser with backtracking, and second one is the top down parser without backtracking, top down parser with backtracking, top down parser without backtracking. And when I'm saying without backtracking, with backtracking, now this with backtracking, the parser is called as recursive descent parser, and when I'm saying without backtracking, then this is also called as predictive parser. We have predictive parser, and this an example is LL1 parser, which is a non-recursive descent parser. This one is a non-recursive descent parser. Okay, and here in case of bottom-up parsers, no, the grammar should not have left recursion, it should not have left factoring, then only we apply the top-down parser. Okay, so you can say no left recursion is allowed, and second is no left factoring is allowed, then only we apply the top down parser. Okay, so we'll start with a simple example of with backtracking, that is what is a recursive descent parser. I'll give you a very simple example of this, a simple algorithm for the with backtracking, or you can say recursive descent parser, and then we'll look at what is a predictive parser, or you can say without backtracking, or you can say LL1 parser. Okay, so we'll start with the top down parsers now.